This video covers solving inequalities covered in Chapter 3, Section 5. So they ask us to solve the following inequality. 5 times the quantity x squared minus 1 is greater than 24x. So the first thing we need to do is we need to make sure our inequality says something along the lines of it's greater than 0 or it's less than 0. We want to do that so that way we know if we're looking at the graph above or below the x-axis. So we need to manipulate our equation so that way it says greater than 0 or less than 0. So the first thing I need to do is I need to distribute the 5 through to the set of parentheses. And when I do that, I get 5x squared minus 5 is greater than 24x. I still don't have it in the form that I need it to be, so the next thing I'll do is move the 24x over to the other side by subtracting 24x from both sides. So that'll give me 5x squared minus 24x minus 5 is greater than 0. Now I know I'm interested where the graph is above the x-axis because it's greater than 0, or where the graph is in the positive values. So I can go about doing this two methods now. We can graph this using the axis of symmetry, the vertex, and the intercepts, or we can solve this algebraically. I'm going to show you how to use the algebraic method in this problem. So the first thing we need to do for the algebraic method is we need to find the x-intercepts. The x-intercepts are also known as the zeros, the roots, or the solutions to the problem. So I need to go through and I need to solve for x in this inequality. And because it's a quadratic, the ways we solve a quadratic would be completing the square, factoring, or quadratic formula. After some inspection here, I'm able to see that this is able to be factored. So I'm going to use AC grouping to factor this inequality. So AC grouping says the first thing you do is you multiply the A and the C values. Where are we? So 5 times negative 5 gives me negative 25. From there you want to list the factors of negative 25. So what two numbers multiply to negative 25? I have 1 and negative 25, negative 1 and 25, and 5 and negative 5. Once I have all the factors listed, I want to determine which pair of factors add to my b of negative 24. The pair of factors that add to b here are 1 and negative 25. So that means I rewrite my middle term using those two new pairs, or that new pair. So it becomes 5x squared plus 1x minus 25x minus 5. Now I have 4 terms. Whenever I have 4 terms, you factor by grouping. When you factor by grouping, you group the first 2 terms and find the greatest common factor. Then you group the second 2 terms and find the greatest common factor. The greatest common factor of the first 2 terms is x, and when I factor it out, I'm left with 5x plus 1. And the greatest common factor of the second 2 terms is negative 5. And when I factor it out, I'm left with 5x plus 1. Looking at this line, hopefully you see the greatest common factor of 5x plus 1. And when I factor that greatest common factor out, I get x minus 5. This is just the factored form, not the solutions to the problem. To find those solutions, we use the zero product property, which says you take each factor, set it equal to 0, and solve from there. So I have my factor of x minus 1 equaling 0, and I have my factor of x minus 5 equaling 0. From here we're going to solve for x in both equations. In the first equation, to get the x by itself, you subtract 1 and you divide by 5. To get x is negative 1/5. And then in the second equation, you add 5 to get x equals 5. So remember, those numbers are the zeros or the x-intercepts or the solutions to the problem. So if I were going through and graphing this, I know I have an x-intercept of -1/5 and an x-intercept of 5. And I know my picture is not to scale, but this shows us how the x-axis is now broken up into intervals. We have the interval from -∞ to -1/5, from -1/5 to 5, and then from 5 to infinity. So what I'm going to do is I'm going to look in each of those intervals, and to make my life a little neater and more organized, I'm going to put those intervals into a table, because in each of those intervals I need to find a value, and then I need to plug that value into the inequality. So my intervals were from -∞. Come on. It's not going to work again. To -1/5. I also have the interval from -1/5 to 5, and from 5 to infinity. The next thing I want to do is I want to find a value in each of these intervals. So if I'm looking at the interval from -∞ to -1/5, I want to choose any value in there. It could be -1,000,000, it could be -330,001, it could be -10.5, it could be -6, it does not matter. But to make my life easy, I'm going to choose a value of -2. Again, choose any value in the interval -1/5 to 5. Again, it could be 1.26789. It could be 3, it could be 5, it does not matter. I'm going to choose 0 to make my life easier. And then choose any value between 5 and infinity. I'm just going to choose 6. So now we're going to go through and we're going to plug each of these values into my inequality or my equation. So -2 squared is 4. 4 times 5 is 20. -24 times -2 is +48. And then I have -5. 20 minus 48, or sorry, 20 plus 48 is 68. 68 minus 5, 63. Next, go through, plug in 0. 0 squared is 0. 0 times 5 is 0. -24 times 0 is 0. Then I have -5. 0 minus 0 minus 5 gives me -5. And then last but not least, plug in 6. Hopefully you can trust me on that. When you plug it in, you'll get 31. So I want to stress here, when I plugged in -2, that a value in that interval, I got a positive solution. When I plugged 0 in from that interval, I got a negative solution. And then when I plugged in 6 from that interval, I got a positive solution. So remember, according to what we were looking at, the inequality wanted to know where the values that were greater than 0 occurred. Greater than 0 means above the x-axis or positive numbers. So the two intervals where I had positive values were from -infinity to -1/5 and 5 to infinity. So that there gives us our solution for the problem. So my answer from -infinity to negative 1/5. In union with, that's the union symbol, not a U, 5 to infinity. Another way that you kind of could have looked at this also is we know the x-intercepts are negative 1/5 and 5, so we could have made a sketch of the parabola. Hopefully you realize the parabola opens up because the a, which is 5, is a positive value. So I know my parabola has to go through those 2 points on the x-axis and it has to open upward. So again, a quick sketch here would give us something that looks like this. And then from there, it's easy to see that the graph is above the x-axis or greater than 0 on the intervals from negative infinity to negative 1/5 and from 5 to infinity.